What if I told you that every single week you may be throwing literal gold into the trash? Or worse, that you are spending your hard-earned money at the garden center on plastic bags filled with synthetic fertilizers and imported manure, while one of the most powerful, nutrient-dense, life-giving foods for your plants is already growing right beneath your feet, and it costs absolutely nothing. Welcome back to Earthly Delights, my friends. Today, we are beginning a journey that may completely change the way you see your yard, your soil, and even the simple act of mowing the lawn. For a moment, imagine the steady, rhythmic sound of a lawnmower. For years, whenever I heard that familiar sound, I thought of mowing as nothing more than another chore, a routine job necessary to keep the yard neat and maintain that familiar suburban look. I would collect those damp, fragrant grass clippings, pack them into bags, drag them out to the curb, and watch the waste truck carry them away. Then, in a perfect example of gardener's irony, I would get into my car, drive to the local nursery, and spend money on expensive, chemical-heavy fertilizers to feed my tomatoes, squash, and other garden plants. Does that sound familiar? Have you ever stopped and wondered why we have separated our lawns from our gardens so completely? Why do we treat the lawn as something that constantly produces waste, while treating the garden as a hungry system that constantly needs us to bring in more resources? Today, we are going to reconnect those two worlds. I am going to show you what feels like a true gardening miracle. But listen carefully, because I am not talking about the rotten, foul-smelling grass water that so many people online teach gardeners to make. The kind of mixture that can make your neighbors complain and leave your entire yard smelling like an open sewer. And I am not talking about traditional composting either. Composting is beautiful, valuable, and necessary, but it can take 6 months or longer, along with repeated turning and physical work, before that material is ready to nourish the soil. No, my friends. In this video, you are going to learn how to use the clean, elegant power of biology to transform fresh grass clippings into a powerful, nutrient-rich liquid plant food in exactly 7 days. A golden elixir that carries the smell of the forest floor after fresh rain offers nutrient availability that can outperform ordinary manure and cost you absolutely nothing. Are you ready to stop buying fertilizer and start producing your own? Let's dive in. The body, the 8-part biological blueprint. Part 1. The nitrogen wealth and cellular chemistry of fresh grass. To understand why this 7-day elixir works so beautifully, we first need to look at the way nature feeds itself. Walk into a pristine, ancient forest and look around. You will not see anyone walking between the trees scattering little blue pellets of chemical fertilizer. You will not find bags of sterilized steer manure stacked around the roots of wild ferns. And yet, everywhere you look, the forest is overflowing with abundance. It is a thick, living tapestry of green growth. How does that happen? Nature works through a perfect, continuous cycle. Leaves, twigs, grasses, and other organic materials fall to the ground. With the help of oxygen and soil biology, they decompose and return the nutrients stored inside them directly back into the root zone. Nothing is wasted. When we mow our lawns, we are actually harvesting an enormous amount of plant biomass. Those freshly cut blades of grass are not waste. They are more like a concentrated vitamin supplement waiting to be used. While the grass is growing, it behaves almost like a solar-powered miner. Through its roots, it draws nitrogen, potassium, phosphorus, calcium, magnesium, and trace elements from the soil, and stores those minerals inside its tissues. At the same time, those grass cells contain active enzymes, amino acids, sugars, and vitamins. Fresh grass clippings also have an unusually low carbon-to-nitrogen ratio, commonly around 20:1. In organic chemistry, that 20.1 ratio sits right in the sweet spot. It tells us that the grass contains a large amount of nitrogen compared with its carbon content, which makes the material highly decomposable. Fresh clippings are also made up of roughly 80% to 85% cellular water and sap. That enormous moisture content means the cell membranes are soft, thin, and delicate. Under the right conditions, those cells can rupture quickly and release their soluble nutrients into the surrounding water. But there is one fundamental rule we need to establish immediately. We must use fresh, recently cut green grass. Dry grass is completely different. Once grass has been left in the sun for several days and has become brown, dry, and straw-like, it has already lost most of its volatile nitrogen into the atmosphere. What was once a nitrogen-rich, sap-filled powerhouse has become tough, carbon-heavy material. For our 7-day super fertilizer, we want fresh green grass that is still bursting with cellular life and ready to release that stored power directly into our brew. Part 2. The anatomy of a mistake. Anaerobic putrefaction versus aerobic fermentation. Now we need to address the elephant in the garden. Why does homemade fertilizer tea have such a terrible reputation? The answer comes down to one classic biochemical mistake: anaerobic putrefaction. Many gardening blogs and video channels tell people to throw grass into a bucket of water, close the lid tightly, place it somewhere dark, and leave it there for 3 weeks. If you do that, the dissolved oxygen inside the water can fall to essentially zero in less than 4 hours. At that point, you have created an anaerobic or oxygen-free death trap. Inside that suffocating environment, anaerobic bacteria begin to dominate. As these organisms slowly digest the grass, they release highly toxic volatile gases, including hydrogen sulfide, which produces that unmistakable rotten egg smell, along with methane and ammonia. The result is not simply unpleasant. That unbearable sewage-like odor can drift across the fence and quickly destroy your relationship with the neighbors. At the same time, some of the chemical byproducts produced during anaerobic putrefaction can be toxic to sensitive young roots. But there is an even more serious concern. Warm, stagnant, oxygen-depleted water can become an ideal breeding environment for human pathogens. If the grass has been contaminated with bird droppings or other animal waste, that warm, oxygen-starved, sugar-rich bucket can allow populations of Escherichia coli, Salmonella, and Listeria to multiply exponentially. So what happens if we change the rules completely? What if, instead of letting the mixture rot in darkness without oxygen, we deliberately invite oxygen into the system? When we keep our brew oxygenated, we encourage a completely different community of microorganisms: aerobic bacteria, and beneficial fungi. These are the good guys of the soil food web. Instead of breaking down the grass through putrefaction, they digest those grass fibers through cleaner enzymatic processes. Rather than producing clouds of foul-smelling gases, they convert nitrogen into stable, plant-available ammonium and nitrate, while helping preserve other volatile nutrients. The result is a fermentation that smells earthy, sweet, and slightly yeasty, more like sourdough bread or freshly made silage than sewage. And what we end up with is a liquid that is highly beneficial for our plants and completely safe for the garden. Part 3. The harvest, gathering and preparing. The biomass our creation begins with the harvest. The ideal time to gather your grass clippings is early in the morning, shortly after the sun has risen. Why morning? During the cool hours of the night, plants experience a process called guttation. Through tiny pores near the tips of their leaves, they release small amounts of nutrient-rich sap. That means morning grass is plump, hydrated, and often covered with those sweet, beneficial droplets. As you mow the lawn, simply allow the mower bag to collect the clippings. It does not matter whether you are using an expensive riding mower, a traditional push-reel mower, or even cutting the grass by hand with shears. What matters is that the grass ends up shredded. Think about what happens when you brew a cup of herbal tea. The smaller the pieces of plant material, the more surface area becomes exposed to the water, and the faster the extraction takes place. The same principle applies here. Finely chopped grass clippings can begin releasing soluble nitrogen, enzymes, and sugars within days, while whole, coarse stalks may require weeks to break down. But there is one safety rule that is absolutely non-negotiable. If you have applied any type of chemical weed killer, synthetic lawn fertilizer, or selective broadleaf herbicide to your lawn during the previous 3 weeks, do not use those grass clippings. Persistent herbicides, such as clopyralid or aminopyralid, do not break down easily in water or compost. If contaminated grass is turned into fertilizer tea and that liquid is poured into your vegetable beds, you can unintentionally poison plants such as tomatoes, peppers, and beans, causing their leaves to curl, deform, and eventually die. Use only grass that has grown naturally and has been nourished by clean soil and rain. Part 4. Water wisdom. neutralizing the microbe killer. Now that we have harvested our fresh green gold, we need to prepare the next essential ingredient, water. And this is exactly where many well-intentioned gardeners experience their first invisible failure. They fill the bucket directly from the garden hose, throw in the grass, and then wonder why the process barely seems to work. The reason may be hidden inside the water itself. Municipal tap water is commonly treated with chlorine or chloramine. Those chemicals are extremely effective sanitizers, and they are added for one primary purpose: to kill bacteria and prevent biological growth. But our entire 7-day fermentation depends on beneficial bacteria and fungi staying alive and multiplying. If we fill our brewing bucket with heavily chlorinated tap water, we can sterilize the mixture, slow or stop the fermentation, and create conditions where opportunistic, chemical-resistant pathogens may begin to dominate. So we need chlorine-free water. Natural rainwater is the gold standard. It costs nothing, tends to be slightly acidic, and contains dissolved atmospheric gases that microbes love. Well water is another excellent option. But if ordinary tap water is all you have, there is no need to worry. There is a very simple solution that costs nothing. Fill your empty buckets with tap water and leave them outdoors, uncovered, in the sun for at least 24 hours. Because chlorine is volatile, it will naturally escape into the atmosphere, leaving behind softer water that is more suitable for biological brewing. If your local water system uses chloramine, however, the situation is different. Chloramine is a more stable combination of chlorine and ammonia, and does not disappear as easily through ordinary off-gassing. In that case, you can speed up the process by running an aquarium air bubbler in the bucket for about 30 minutes, or by adding a small pinch of vitamin C, also known as ascorbic acid, or a spoonful of humic acid to neutralize the chemical bond immediately. Part 5. The golden ratio and container setup. Now it is time to assemble our fermentation vessel. You will need one clean 5-gallon or approximately 20-liter plastic bucket. For an ordinary backyard garden, this size is almost perfect. It is lightweight, easy to move, simple to stir, and can produce enough concentrated fertilizer to feed roughly a 200-square-foot vegetable bed. The golden rule for our mixture is wonderfully simple. Fill exactly half the bucket with fresh, loose grass clippings. And the word loose is important. Do not press the grass down. Do not compress it into a thick, dense mass. We want those clippings resting freely inside the bucket, with enough space between the blades for water, and especially dissolved oxygen, to move through the entire mixture. If you pack the grass tightly, you can create anaerobic pockets hidden deep inside the mass. Those oxygen-starved zones can immediately begin to putrefy and produce the exact sewer-like smell we are trying to avoid. Once the loose grass reaches the halfway point of the bucket, slowly pour your dechlorinated water over the top. Continue filling until the water level stops about 4 inches, or roughly 10 centimeters, below the rim. That empty headspace is important. As fermentation begins, the liquid will start bubbling, expanding, and creating a thick layer of active foam. We need to give this living brew enough space to move and breathe without overflowing onto the ground. And remember one of our most important rules: never seal this bucket with an airtight lid. We need constant gas exchange with the surrounding air so carbon dioxide can escape and fresh oxygen can continue entering the system. Instead of using a solid plastic lid, cover the opening with cheesecloth, an old cotton t-shirt, or a fine mosquito net. Secure it firmly around the rim using twine or a bungee cord. That simple screen will keep falling debris and curious insects out, while specifically preventing disease-carrying mosquitoes from turning your nutrient-rich liquid into their own breeding nursery. At the same time, the microbes inside remain free to breathe. Part 6. The surprise catalyst and the forest inoculant. Now we come to the secret weapon, the surprising kitchen ingredient that can transform an ordinary, slow 2-week soak into an explosive, energetic 7-day biological process. That ingredient is simple white granulated sugar. For every 2.5 gallons, or approximately 10 liters, of water in your bucket, add 2 heaping tablespoons of sugar. You can use white sugar, brown sugar, or even unsulfured molasses if you already have it available. But why would we put sugar into plant food? We are not trying to sweeten the soil, and we are not feeding the plant roots directly. The sugar acts more like a high-octane energy drink for the beneficial aerobic bacteria naturally living on the surface of the grass. Under ordinary conditions, those bacteria must spend energy producing complex enzymes that allow them to break apart the tough cellulose in grass before they can access their food. When we give them a small amount of easily digestible simple sugar, we provide an immediate metabolic spark. Their populations begin multiplying exponentially, expanding into billions of organisms within only a few hours. That enormous army of energized bacteria can then direct its combined enzymatic power toward the grass fibers, breaking down cell walls and releasing nitrogen, potassium, and minerals into the surrounding water much more rapidly. But we can push the process one step further. If we want the brew to be dominated by some of the most powerful microorganisms available in nature, we can introduce a natural inoculant. Take a walk through your yard, a local park, or a nearby wild Part 6. The surprise catalyst and the forest inoculant. Now we come to the secret weapon, the surprising kitchen ingredient that can transform an ordinary slow 2-week soak into an explosive, energetic 7-day biological process. That ingredient is simple white granulated sugar. For every 2.5 gallons, or approximately 10 liters, of water in your bucket, add 2 heaping tablespoons of sugar. You can use white sugar, brown sugar, or even unsulfured molasses if you already have it available. But why would we put sugar into plant food? We are not trying to sweeten the soil, and we are not feeding the plant roots directly. The sugar acts more like a high-octane energy drink for the beneficial aerobic bacteria naturally living on the surface of the grass. Under ordinary conditions, those bacteria must spend energy producing complex enzymes that allow them to break apart the tough cellulose in grass before they can access their food. When we give them a small amount of easily digestible simple sugar, we provide an immediate metabolic spark. Their populations begin multiplying exponentially, expanding into billions of organisms within only a few hours. That enormous army of energized bacteria can then direct its combined enzymatic power toward the grass fibers, breaking down cell walls and releasing nitrogen, potassium, and minerals into the surrounding water much more rapidly. But we can push the process one step further. If we want the brew to be dominated by some of the most powerful microorganisms available in nature, we can introduce a natural inoculant. Take a walk through your yard, a local park, or a nearby wild forest. Look for a healthy, mature tree, perhaps an old maple or oak that has been growing there for decades. Carefully move aside the dry fallen leaves around its base until you reach the dark, moist, sweet-smelling layer of soil sitting close to the surface. This material is leaf litter, or leaf mold, and it is a living biological nursery. Take one generous handful of that wild forest soil. It is naturally filled with beneficial mycorrhizal fungi, nitrogen-fixing bacteria, and trichoderma, a powerful fungus that helps protect plant roots from disease. Drop that handful directly into your bucket. By doing this, you are inoculating the grass brew with a diverse, localized community of native microorganisms that have adapted over thousands of years to cycle nutrients and defend plants. It is almost like inviting a team of expert biological engineers into the bucket to guide the entire fermentation process. Forest. Look for a healthy, mature tree, perhaps an old maple or oak that has been growing there for decades. Carefully move aside the dry fallen leaves around its base until you reach the dark, moist, sweet-smelling layer of soil sitting close to the surface. This material is leaf litter, or leaf mold, and it is a living biological nursery. Take one generous handful of that wild forest soil. It is naturally filled with beneficial mycorrhizal fungi, nitrogen-fixing bacteria, and trichoderma, a powerful fungus that helps protect plant roots from disease. Drop that handful directly into your bucket. By doing this, you are inoculating the grass brew with a diverse, localized community of native microorganisms that have adapted over thousands of years to cycle nutrients and defend plants. It is almost like inviting a team of expert biological engineers into the bucket to guide the entire fermentation process. Part 7. Mechanical aeration, the breath of life. At this point, we have our fresh grass, dechlorinated water, sugar catalyst, and forest inoculant. Now we arrive at the most critical step in the entire process, the simple daily ritual that separates a sweet-smelling, powerful liquid fertilizer from a bucket filled with rotting, toxic sludge. We must physically introduce oxygen into the brew through mechanical aeration. At least twice every day, once in the morning and again in the evening, go to your bucket, remove the cloth cover, and stir the mixture vigorously using a long wooden stick or a clean plastic pipe. And I do not mean a slow, gentle little swirl. Agitate that water with energy. Stir hard enough to create a deep whirlpool in the middle of the bucket, and make the liquid splash strongly against the sides. That vigorous movement accomplishes something incredibly important. It physically pulls fresh atmospheric oxygen down into the water, where it dissolves and helps keep the entire environment highly aerobic. At the same time, the movement knocks multiplying bacteria away from the grass blades and distributes them throughout the liquid, allowing them to reach new sources of food. Think of this daily stirring as the heartbeat of your fertilizer. If you forget to stir the mixture for only 2 days, biological activity can consume the remaining dissolved oxygen. The aerobic microorganisms begin to suffocate and die, while foul-smelling anaerobic pathogens move in and take control. But when you give the brew those 2 strong, vigorous stirs every single day, you keep the system active, clean, oxygenated, and sweet-smelling. Now, where should we keep the bucket during these 7 days? Temperature is the engine of biological activity. If the bucket becomes too cold, microbial activity slows down, and the entire process may stall. If it becomes too hot, the water can overheat, effectively cooking the grass and killing many of the beneficial organisms we are trying to encourage. The ideal location is warm shade. Place the bucket beneath the canopy of a tree, on a covered porch, or in a protected corner beside a garden wall where it remains sheltered from harsh, direct midday sunlight. For these 7 days, think of your fermentation bucket almost like a temporary living pet. It needs fresh air, a comfortable temperature, and a small amount of loving attention every day. Part 8. The Reckoning. Reading the Cues, Dilution, and Application. As the 7 days pass, your bucket will begin moving through a fascinating series of changes in appearance, texture, and smell. By around the 3rd day, the water that originally looked clear will begin turning cloudy, with a yellowish-green color. That change is visible evidence that the grass cell walls are starting to break apart and release their sap into the liquid. When you stir the mixture, you may also notice a thick layer of white, frothy foam forming across the surface. Do not be alarmed. That foam is not a sign that something has gone wrong. It is a badge of honor. It is living evidence that the bacteria are active, breathing, consuming the sugar, and working at full speed. At this point, the smell should still be fresh, green, and slightly sweet, similar to the scent of a newly mown pasture early in the morning. By the 5th and 6th days, the greenish liquid will become much darker, developing a rich brown color that resembles strong black tea or lightly brewed coffee. The grass clippings that floated near the surface during the first few days will begin losing their original cellular structure. They will soften, darken, turn into a mushy mass, and slowly sink toward the bottom of the bucket. Then comes day 7. Now it is time for the final examination, the smell test. Bring your nose close to the surface of the liquid and breathe in carefully. If you have aerated the mixture successfully, the smell should be clean and earthy, like wet soil after a summer thunderstorm, mixed with a light, sweet, and yeasty aroma that may remind you of sourdough bread or baker's yeast. If that is what you smell, you have succeeded. You have avoided the foul, putrid odor of anaerobic decay and created a clean, living biological elixir. But before this liquid treasure goes anywhere near the garden, we need to strain it. Place a piece of burlap, an old cotton shirt, or a fine kitchen strainer over a second clean bucket. Then slowly pour the mixture through the material, separating the liquid from the remaining grass pulp. And here is one golden rule. Never throw that leftover grass pulp into the trash. It still contains valuable organic matter and slow-release carbon. Take the soft grass material and spread it around the base of fruit trees or berry bushes as mulch. There, it can work like a protective blanket, helping the soil hold moisture, suppressing weeds, and continuing to feed the earth as worms gradually pull the material below the surface. Now we need to talk about dilution. Our 7-day grass fertilizer is an extremely powerful biological concentrate containing high levels of readily available nitrogen. If we pour that concentrate directly onto our plants, especially young, delicate seedlings, the high nitrogen concentration can create osmotic shock, drawing water away from root cells and causing what gardeners call fertilizer burn. So we follow one universal safety rule: dilute it at a ratio of 1:10. For every 1 cup of concentrated grass elixir, mix in 10 cups of clean, chlorine-free water. Once diluted, the finished solution should look like extremely weak black tea. That is the gentle concentration we are looking for. Strong enough to encourage rapid growth, but diluted enough to protect sensitive roots. For very young seedlings or delicate plants growing in containers, you can extend the dilution to 120 for additional safety. So how do we apply this liquid gold? The simplest and most common method is a direct soil drench. Fill a watering can with the diluted mixture and pour it around the base of your plants, thoroughly soaking the root zone. The soil behaves like a sponge, absorbing the liquid nutrients almost immediately. Unlike granular synthetic fertilizer, which can take weeks to dissolve and may leave harsh chemical salts behind, this liquid fertilizer can be absorbed by plant roots within hours. Within days, you may notice your plants making a dramatic leap in development, with leaves turning deeper and more vibrant green, while stems become visibly thicker. There is also a second highly effective method: foliar feeding. Plant leaves contain microscopic pores called stomata, which allow them to breathe and absorb moisture. By pouring your diluted fertilizer into a garden sprayer, such as the reliable Chapin International 20,000, you can apply a fine, gentle mist directly across the foliage. But timing matters. Foliar feeding should only be done very early in the morning, before the sun rises high into the sky, or later in the afternoon as the sun begins to set. If you spray the leaves during the hottest, brightest part of the day, water droplets can behave like tiny magnifying glasses, focusing sunlight and causing severe, permanent burns to delicate leaf tissue. And there is one final food safety rule we need to respect. Always observe the 90 to 120-day pre-harvest interval. Never spray this foliar fertilizer directly onto edible leaves that you intend to consume raw, such as lettuce, spinach, or herbs, within 90 days of harvest. For root vegetables or crops where the edible portion comes into direct contact with the soil, extend that interval to 120 days. In a healthy garden, safety and hygiene always come first. Conclusion: cultivating your future. As we bring this circle to a close today, I want to step back for a moment and look at what this really means. That simple 5-gallon bucket of fermenting grass represents far more than a free substitute for chemicals bought at the store. It represents a shift in consciousness. It is a small act of defiance against a consumer culture that has taught us to believe that every problem requires us to purchase another product. Every time we buy another bag of synthetic fertilizer, we bring chemical salts into our gardens and yards that, over time, can compact the soil, disturb the delicate network of mycorrhizal fungi, and eventually wash into local watersheds, contributing to ecological dead zones in rivers and oceans. But when we look differently at our own lawns, gather those grass clippings, and combine the simple forces of water, oxygen, and sugar to nourish our gardens, we begin participating in something much older and more beautiful. We join an ancient natural dance. We recognize that we are not separate from nature. We are part of it. Think about how much abundance is already surrounding you. During winter, kitchen scraps can be tucked directly beneath a layer of carbon-rich mulch, where earthworms can gradually process them in place. In spring, you can grow nitrogen-fixing clover cover crops that move fertility directly into the root zone. And during summer, every single time you mow your lawn, you are harvesting another fresh supply of green gold. Our plants do not belong in sterile dirt that depends entirely on chemicals for fertility. They deserve to grow in living soil, a thriving, vibrant, biologically diverse community beneath our feet. And starting today, you have the power to begin building that community with your own 2 hands. So I want to leave you with one question to carry into your garden this week. What other hidden treasures are already growing beneath your feet, simply waiting for you to notice them? And how can you begin working with the earth instead of constantly trying to control it. If this journey has changed the way you see the grass clippings in your own yard, subscribe to Earthly Delights, hit the like button, and share your experience with us in the comments below. Let's grow our future together, one bucket at a time. Until next time, my friends, keep your hands in the soil, keep your heart open, and keep enjoying the beautiful magic of the earth.